All right, to talk about inequalities here, this is from your textbook, but essentially just to give you an idea here of how these work. I mean, you're going to have here that, x is greater than 4, and what that means is there's a little hole right here. We don't actually draw a solid dot, sorry, not a solid dot. We draw a little circle, just to illustrate that it's not 4, but it's actually greater than 4, and you'll see that common throughout this whole thing. X greater than or equal to 4, then we draw a solid dot right here. So there's a solid dot as opposed to a hollow one. Because then it includes it and it's greater, or it's less than 4, or it's less than or equal. And you'll start seeing this on a number line in terms of what inequality means. But here's some basic definitions. Some properties about this. Essentially, the properties are exactly the same as they would be for equality. You'll notice that you can add things on both sides as long as you add the same constant on both sides. It's fine. You can subtract, you can multiply. The one that throws people off is if you divide. And just to show you here, I'll give you an example here where A is greater than B, but if C is less than 0, in other words, C is a negative number, then things mess it up. And I'll show you why that is. Suppose I had a statement that said that 6 is greater than 2. That's correct. 6 is greater than 2. But what if I divided both sides by, let's say, negative 2? Well, if you divide both sides by negative 2, look what happens. If I divide this by negative 2 and this by negative 2, if I left this symbol the exact same, what you're going to have is you're going to have negative 3 is greater than negative 1, which is a false statement. That's not actually true, so that's not true. And so what we have to do is we have to flip this around. So in fact, I should have said negative 3 is less than negative 1. If it says less than or equals, or greater than or equals, that's okay. In other words, if this one originally said, 6 is greater than or equal to 2, when I switched it around, I could have said negative 3 is less than or equal to negative, negative 1. Now again, I know this isn't true, it's not equal. I'm just showing the purpose that if it does originally say equals, it's okay, because when we do switch things around, it still equals. It's the greater than or less than that we have to flip if we're ever dividing by a negative number. In other words, something that's less than, less than 0, then it's a negative number. But that's how we're going to deal with some of these basic properties of this. I'll go through some examples here in just one moment.